The Liskov substitution principle simply states that subtypes must be substitutable for their base types. This principle is named for Barbara Liskov, who first described the principle in 1988. This motivational poster sort of drives home the idea that if you have an abstraction that looks like a duck and quacks like a duck but needs batteries, it's probably not the right one. So in this case, you could say that the rubber ducky that requires batteries is a duck, but it certainly isn't substitutable in all places where you would expect to have an actual duck. In order for substitutability to work, the child classes must not remove behavior from their base class, nor should they violate base class invariance. In general, calling code should not know that there is any difference at all between a derived type and its base type. One of the things that many software developers learn early on in their education when they learn about object-oriented development is the use of the is-a relationship to describe inheritance. It's very common to say that a particular class is a whatever base class it is. For example, one might have an employee class that is a contact, that is a person, or you might have a square that is a shape, or a car that is a vehicle. This is a very common tool, and what the Liskov substitution principle suggests is that rather than simply considering whether or not some noun is another noun, you should instead consider whether or not it is substitutable for that other noun in all situations where one might expect it to be. This is most easily seen through the use of an example, which we'll get to in a moment. Now, one of the things that is important when we talk about the Liskov substitution principle is this concept of invariants. Invariants are things that have to do with the integrity of your model that your classes represent. So they consist of reasonable assumptions of behavior by clients, by other classes that make use of your class. These can often be expressed as preconditions and postconditions for methods, and they're not necessarily indicated within your code. Frequently, unit tests can be used to identify what the expected behavior is for a given method or class, and these unit tests should fail if that behavior is broken or changed by a subtype that violates it. There's a practice called design by contract, which is a technique that makes defining these pre- and post-conditions explicit within the code itself. And there are a number of ways that you can use design by contract with C#, but those are beyond the scope of this particular session. In order to follow the Liskov substitution principle, derived classes must not violate any of the constraints defined or assumed by clients of their base classes. Let's look at an example of how Liskov substitution principle violations can cause problems